In this video, we're going to learn how to get the solution set to inequalities with two variables. Now, before we do that, I want to very quickly just review how to get the solution set for an inequality with one variable. So let's say that we have x minus 2 is greater than 4. How would we get the solution set for this? Well, you would have to first solve for x. In this case, I'm going to add 2 to each side, and I end up with x is greater than 6. So we have a solution set here. And then in order to graph it, I'm going to plot an open circle and indicate with an arrow to the right that all the values to the right of this 6 are going to be possible solutions in the solution set because they are greater than 6. This part is really important. As we move on to getting the solution set to inequalities with two variables, we are no longer going to be graphing in one number line because we have two variables. This one number line only occurred when we had one variable, in this case x. So in a sense, this number line represented x. But once we move to two variables, and so what will happen is that we will start graphing in a coordinate plane so that one number line, the horizontal one, is representative for the x-axis and the other one for the y-axis. So I have 4 examples here of inequalities with two variables. Before we get started, the one thing that is super important for you to remember about graphing inequalities in a coordinate plane is that symbols are really going to be important in determining how you graph it. So for example, let's say that I only had one variable, and if I had x is less than or equal to 20, in my x-axis, I would graph that as 20 with a closed circle because it actually includes the equal sign. And then I would indicate all the numbers to the left, which are less than 20, right? But in this case, of course, that's not how we would graph this because we also have the y. But the reason I brought this example to your attention is because we have to look at whether or not the inequality symbol includes the equal sign. If it includes the equal sign like this particular problem does, then you want to include the values. And in cases where you don't have the equal sign, like in my example C over here, you do not include, because you don't have the equal sign, you do not include the actual numbers, then you want to keep the spirit of the open circle, and you're not going to graph it with a straight line. You're going to graph it with a dotted line to indicate that we are not including those values that the line is on. So let's go ahead and get started on the actual procedure of how you can graph a solution. The first thing you need to do is isolate the y. You want to have the y by itself. So let's go ahead and start moving and rearranging our formulas. In this case, I would have to move x to the other side. And then what I would have is y is less than or greater than negative x plus 20. You always want to write the x immediately after the either equal sign or inequality. That's just good practice. This form actually has a name to it that you will learn later on in algebra, but not for today's lesson. Once you arrive at that form, you have two incredibly important pieces of information. That is going to be your slope of the line. And then we also know that this is going to be your y-intercept. And so what you're going to do is you're going to use this information to graph. We're going to go ahead and find the number 20 in the y-axis. And then I'm going to use my slope, which is a negative 1. If you remember, slope is rise over run. Then what I have to do is from the number 20, so I'm going to down 1 and 1, down 1 and 1, down 1 and 1, and I'm going to continue that procedure until I have my line. Now, because this includes the equal symbol, I'm going to make a solid line. The next step now is to grab a test point. So I'm going to grab a test point to the right of the line, and I'm going to grab a test point to the left of the line. When you're graphing an inequality, you have way more ordered pairs that are part of your solution set than if you were graphing a line, because you actually have a whole area that is covered full of solution sets. So you want to make sure you're trying to figure out what area this is. Is this going to be the area to the right or the area to the left? So this particular order pair is 10, 30. 10 is my value for x, 30 is my value for y. I'm going to go ahead and plug it into my original equation. 10 plus 30 should be less than or equal to 20. That, of course, is false. So I know that the area to the right is not going to conclude a solution set. Now let me plug this in. This is a 0 for x, 10 for y. And that is true. So I'm going to go ahead and shade all the numbers that are to the left of this line to represent that these are all possible solutions to this inequality. Let's move on to the next example. I'm going to first move my x to the other side. All right, and then I'm going to find my y-intercept. And my slope here is -1/1. Now, because this inequality does not have the equal sign, I'm going to just keep my dotted line and not fill it in as a solid line, because I'm not going to actually include the points that are on the line. Now I'm going to grab some test points. I'm going to plug them into the original equation. This, of course, is false. Let me plug in the other one. And that, of course, is true. So I'm going to go ahead and shade everything to the left. That's pretty much it. That's how you graph an inequality. Go ahead and graph B and D.